Well done. Thank you all for coming in. So yes, my name is Liran TAL, and hope today we're going to learn a bit about practices that developers practice day to day, but why that's also potentially security issues for basically everyone here and what's on your mind. So I'm a developer advocate at Snyk, which is a company that builds developer-first security tooling. So as a person in the space of being a developer myself, it's a really great way to kind of like transition into helping developers learn about security, everything from starting with the basics of the general OWASP top 10 and a bit more than that. So I've been doing security and practicing that through several ways, through my work with the OpenJS Foundation, through open source, basically building tools and all of those kind of things. And I thought I'll kind of like maybe break the ice first, I guess without the hat. Also, I'm a huge hugger, and COVID kind of like ruined that for a bit, because prior to that, I was actually wearing that sign that said free hugs and walked through the Snyk office with it. So this was fun. The other thing that I do for fun and my own, kind of finding really good things to do on the weekend, I guess, is things like security research. So one of those developers who actually, sit down, help try to kind of like break down a security problem, but also try to break it down in a way where I actually understand it. So I actually do a bit of security research myself and have disclosed quite a bit back in May. Other things that we kind of do to help developers is usually cheat sheets. So if you think about it, you all are probably working here with development teams. So as developers, they go to different places than yourself to find about, the latest Active Directory and, other kind of systems that get hacked and other things like that, right? They go to developer blogs. They go to sign up for newsletters. So we kind of take this, approach of building, researching, and building those kind of security resources for developers to really give them a way to learn in the way that they like learning, in the way that actually is good for them. So besides doing that, another aspect of being a developer advocate is essentially this user-facing kind of role actually allows me to connect more with upstream communities. So I'm actually, for example, really on top of many incidents that may happen in the Node.js ecosystem. So I actually work with the CNCF Foundation to document and have all of those in place, work with the OpenJS Foundation to triage vulnerabilities that researchers like probably yourselves probably send as reports to the NPM registry and kind of go through that, triage it, CVE it, CVSS it, etc. Last thing that I actually love doing, and I'll talk about some of this tooling as well, is actually build some of this security tooling. But as a lot of people have come here on the stage and shared what they build for you, for red teams and blue teams, I actually do that for developers. So I like building developer security tooling myself. Most of this, actually all of this is open source. Most of this is kind of like, on my GitHub profile. You can go there and find it. This, for example, called NPQ. So we'll talk about NPM for a sec, throughout the stage. But as we go basically through the stage of talking about supply chain security, developers sometimes, don't really understand the whole context around some of this. So building proactive tools like NPQ to essentially stop them from installing a malicious package before they install it is really going to go a long way. So with that all said, this is what developers feel when they go and do npm install, which is your classic brew install or pip or whatever you're using. Essentially, there's this whole supply of packages, and this is how they feel about it. And probably you as well, if you do Node development or JavaScript development for scripting or something else, when you do npm install, you take a massive risk. And I'm here to tell you, as well as all of these other developers, that this emotional, really deep kind of hit that we take is for a reason, for a very good reason. Through my work, I read a lot of security articles. One of them, or a few of them, which I'll highlight here, kind of give you the glimpse of why this npm install running this command is so deep. One of this from Zimmerman et al. Actually went on to research differences between npm and PyPI as an ecosystems, and it showed us that by running that npm install, the average npm install command actually brings in something like 80 third-party dependencies, and maybe about half of that as we lay trust on other open source maintainers, potentially different of them. That's what happens when you and your developers do npm install and you install a lot of packages. Further out, what's the risk with those packages? This is actually a very, very recent article. That's from February 2022. Highly recommend reading it. What are weak links in the npm supply chain? Essentially, what happens a lot in this ecosystem is account takeovers. Because if there's a package that gets millions of downloads a week, if someone can take over that package and add some malicious code into it, which happened multiple times, then essentially it's game over for an ecosystem. So here is an example of just using expired domains to essentially take over that domain and then take over that package through password reset and the whole kind of flow through that. But actually, in fact, when we think about all of this, all of that is nothing new. It's nothing new because this has been happening for a long, long, long time. About 4 decades ago. Reflections on Trusting Trust is an essay that was written by Ken Thompson, an Turing Award-winning developer known for other things, like C and other kind of small software that we may have used today, like the kernel and things like that. And he had written this article and tried to say, trust really goes a long way, but the issue is where do you put the line? Where does it stop? Right? And to do that, he wrote this essay and gave an example and said, hey, I'm going to go ahead and backdoor the Linux login program. Not a problem. Go ahead, add a backdoor to the C code. Hopefully no one catches it, and there we go. You had a backdoor there. But not essentially that, because people review it. So let's go and add a backdoor to the compiler code, so when it compiles the C login program, we can go ahead and add the backdoor there. But people review that code as well. OK, how does compilers get compiled? Using another compiler that was built before. So he went on with this chain of attack and actually added the backdoor to the binary compiler that when that compiles the compiler and the login program in consequence to that, that's when the backdoor is added. And the whole point of this experiment that he did was basically to show us that we have to trust something, someone, somewhere. Unless I basically built this keyboard and this Wi-Fi and everything around it, I can't completely trust it. So obviously, probably nothing new to yourselves. But as we take that onto this world of supply chain, this is the amount of NPM packages, open source libraries that developers use day to day, available to consumption. For developers, this is heaven, because we do not need to reinvent anything new. We can just take something and focus on core business logic. For us, looking at it from a different lens, this is essentially a supply chain, or a supply chain security incident potentially going to happen soon or not. So with that said, how is all of that connected to XSS? Well, in several ways, and why are we even talking about XSS and cross-site scripting for the web in 2022? Especially when the topic here is mostly React, a framework that is very modern, has been, I would say, structured from the bottom of it to basically mitigate XSS attacks. So here's an example from Twitter. I hope some of you see it. If you're not, I'll go ahead and bring this one up and zoom in, and you can read the code. The interesting part here, this is someone sharing their learning of doing React code. This is hooks, basically called use effect here. It's calling something to, when a component is mounted on the DOM, it's supposed to do something, but it gets this something, this other value thing, using native API of the browser. And when that happens, that's a game over, because that's where XSS is added. So the framework may have different issues in it that we need to understand as developers. And so obviously, copy-pasting this kind of code is something bad, and we'll see how that's actually happening in action, but also like different types of vectors that go in. So how does React actually, like, why do we say even that it's secure? And I'm going to say mostly secure by default, not really fully. Which for a lot of developers, like, what? What do you mean? Like, it's 2022, we use React, we use Vue.js, Angular, all of those kind of like modern front-end framework. They're all kind of designed to be secure. What do you mean mostly? So for developers and for you to understand exactly what it means, we kind of need to go through a bit of like, how does React does cross-site scripting? And I'll probably switch to that as the audience here is very aware of this to an extent. So when React renders something using this JS6 code on the top and gets some kind of value, like that first name is my name with a script inside it, what actually happens? So what React does? What does it do today that it didn't really do for the web 10 years ago? Well, it puts that into the DOM, but not exactly as it is. It actually takes all of those dangerous characters that could potentially add and introduce new HTML input elements and sends them or encodes them into these web entities, HTML entities that represent what they would be. So in our security lingo, we are understanding this as output encoding, but completely unaware for many developers that this is what is happening or this is how it's protecting them. And we'll see how all of this connects to developer security when they go and develop these apps in their businesses. And so when we say that React is secure, we actually mean that it does output encoding by default on user input. Well, surprise. Mostly. It doesn't always do it. There are some cases where it doesn't happen, and that's where we're going to dive into a bit of live coding throughout this whole fun part of this talk, the end of the day, so I'm going to hope that you're all going to have some fun with me as well. So if you get the reference for who is Kate Libby, raise your hand. Yes, do we get a reference? OK, some fun folks here in the crowd. And we're basically going to have an application which is kind of going to mimic something like an NPM, like a registry, like Maven, Central, and things like that, where you post packages. So we have some data and some kind of like a package data to work around with. And of course, every maintainer, what they really, really want is not more issues and not more pull requests. They really want a bit of fame, so we need to add this Twitter link here. And it sounds like super simple, like user input, Twitter, let's go, and that's it. So hacking React take 1, and we're going to go straight into our live session here. So we're going to spend a lot of time here, so bear with me here. This is completely live coding and a fun part with you. So this is the app. Seems to be working. I'm running this off of a container here. Looks like it's working. It should be auto-reloading as well, which we'll try. And this app has, go ahead and do a bit of zooming here. This app actually has a database, which for the sake of essentially trying to simplify this, I did not build the whole API thing, which we do not need to go into, but just a JSON object which represents the database. So anything we change here is essentially data that got into the database, and that's how the React front-end application reads it. So far, so good. This is our code base. As you can see, I did not give you an hello world with a React application of 5 lines of code, because this is not real-world React applications. They are very lengthy. There are many components. There are many views, many, many, many lines of code that actually represent the application. So, and feel free to engage with me, but let's see. Right now, we have this Twitter Kate Libby here as the URL here, and if I'll press it, I'll probably go and visit Twitter, that address. There we go. Say it's open here. I'll close it. So first thing to inject an XSS would be, feel free to engage, or we can try it out just here. Let me help you out. OK. Everyone knows what this is going to do, right? Too much coffee or not enough? OK. So let's refresh anyway and click this follow me and alert. Now, this is an aha moment for a lot of developers, because what do you mean alert? Didn't you just say React is modern, secure framework? Wasn't that the whole premise of building front-end frameworks? And I'm only using React APIs. I am not using escape hatches like dangerously set inner HTMLs. Let me show you how it works. I've got my database here that I've imported, which is essentially just a JSON, and no actual difference from getting that to something else, like getting the actual API request. And I've simply added it here. There's a button component. There's an href database Twitter link. That's it. Everything here, everything you see here is pure React. There's no DOM APIs directly interacting with just this one. So what's the actual issue here? Like, why are we seeing XSS being employed to this application? Because React was supposed to be secure. Well, the thing is, it doesn't encode anything that is values of attributes of HTML elements. OK, so if this is the href value of some HTML element, that does not go into encoding. If I had an entire whole input here as a JS6 that came in as that script alert or something, yes, that would get encoded. But this is not the case. This is just an href value. So let's have more fun and try to fix it. Do you know how developers fix things? Let's do it together. We have any React developers here to help me out, or? OK. Everyone sees what's getting auto-completed there. That is actually GitHub Copilot running here. This is an AI extension that's helping me code. Actually pretty funny. Let's see. First off, I'll go ahead and try to fix this whole thing. So this is what developers do to fix it. I'm going to use database Twitter link as the default value. And then, as we've seen, the way to apply these effects when the page gets rendered onto the DOM is this use effect callback, which I'm not even developing at this point. I'm just letting this AI complete everything. Hopefully, it's done a good enough job. So here we need to actually set it to, well, we'll set it in a second. But what we want to do to sanitize this is how developers see things, right? If this input is JavaScript colon something, I probably need to detect it and remove it. So I'll go ahead and do something like if Twitter link, which is what we get as a value, has an index of JavaScript with a colon at len 0. Oh, there we go. So this is AI completed code. So we do not need developers anymore. Maybe. We'll see. Let's see if this works. So what's happening here? I need to fix some things here that it auto-completed. And there we go. So this line says if we find that the value starts with JavaScript, and I used start with because you may have a URL that has the JavaScript title later on or whatever, and that's in position 0, so it actually starts with this, and equals 0, then we're going to set it to nothing, to a hash. So if I refresh this and try to click it, oh, should I do something else? Well, that's still working, so did not really help. Oh, you know why it's working, right? We forgot to update this part to actually not get from the database to use our sanitized link. So, debugging live. Let's see. OK, job well done. I'm clicking it. Nothing is really happening. Sanitizing. So can we push to production? Yay, it's also Thursday. I don't know. Do we need tests or just shoot it out? Shoot it out? Cool. What did we forget? OK, let's try a different way to attack this. Assume a developer sent it off. Let's say you're a really, really, really smart hacker, and you're trying to bypass this. What do you try? Thank you so much. Try uppercase. Refresh. Oh, XSS exists. OK. What do developers do? Thank you. Lowercase. Correct. Easy fix for that one, I guess. Job well done. Let's see. Yes, well, job well done. So I can do lowercase, uppercase, ready to push this to production. It's also Thursday. Want to go on the boat ride pretty soon. Yeah, we good? I see some skeptic people, as if they know something else is going to pop up. OK, so let's see. What if I add some control characters? The moment I show this to developers, they're like, what's control characters? Right? Like, I have not thought about CRLF or something else. OK, so let's try that one. Refresh, and XSS again. So hope you enjoyed this part, because it brings us into understanding several things here at this point of the demo. OK? First of all, as we said, React is not encoding those href value attributes. So when you code review it, when you want to work on guidelines with your security champions and developers, know to tell them those kind of things. OK? Understand exactly how things work. The thing that is somewhat, I guess, very obvious to you, like deprioritize things like working with a deny list like we had here, like sanitizing it for the right values, is, as you saw, a really, really, really bad countermeasure. And I'm pretty sure a lot of the security people here understand that. Developers may not. Okay? The obvious things to do things to fix them might not be the right way. So this is where security and developers need to work together, because developers may not be super proficient with all the security skills that you know how to mitigate those things. So let's try something else. Let's try having our package manifest. We said this is an NPM registry kind of thing for packages. You can host them. And I have package.json, which I actually want to show it like this. Now, I really want this app that I'm building to be really, really cool and show the package.json and indented like this, and be nice having this code highlighting and all of those things. So I can go ahead and write some code to do this, or why should I write the code if I have this already done for me? So here's really, really, really simple steps, 3 of them, to basically get that functionality for me as a JavaScript developer. I go to the CLI, run npm install, and save this React.json pretty npm package that does what I just showed you. The next thing I need to do is run JSON import and get that JSON pretty into my component if I want to wrap it or just directly use it as is, and then literally use this front-end component to render everything. So it gets from the props the data. This is how data flow in React to subcomponents. For example, this props.package manifest is the package.json value, the actual value. And then I can theme it. I can tell it how many spaces to indent it. Pretty cool. As a developer building web applications, I've done minimal work and got something that looks pretty nice, like this. Well, let's go back there. Yeah, we're at hack 2, if you haven't noticed. So I'll scroll down here, wheel application. By the way, if you want to fund Kate Libby says, talk to me about it afterwards. The Hackers 3 movie might be making a comeback. We'll see. But package manifest, here it is. This is real code. It's actually showing in here. And what we might want to do is show you how things go bad there, right? Let me open specifically my, let's go back here to the component that is actually rendering this. So package parser. OK, this is the code that I just showed you. JSON pretty, export default package parser. That's what I got. As easy as that. And we have this in the web app. That's it. Now, if you were trying to think how to attack this kind of system as an outsider, there's some texture getting rendered to the page. And you, as the user of a package, are in control of the data of the package. So one of the immediate things that you might try to do is change some of those text, right? So instead of a name, maybe add something else. Let's play around with it. So we'll go ahead and remove this so it doesn't confuse us anymore. Oh, by the way, has anyone seen GitHub Copilot in action before? Any hands for GitHub Copilot in action? Few of them. OK, let me show you some cool stuff here. Let's say this testimonial is by Kate's friend, who is, you must have seen Hackers, so who's her friend? No? OK. Very weird security audience. Not a 0 day. How about 0 cool? You know who this is? Yes? OK, great. He has this line which is like mess. Do you know this one? Mess with the best. Do you know what the rest of this line is? Die like the rest. There you go. This is auto-completed by an AI. Pretty freaking cool. But let's go back into the package manifest for a second here. So I can go here and do something like image srcx on error. Yes, alert. And let's see if that works. I mean, this is super simple. I can just change this. And you see automatic reloads. And the page got updated. Nothing bad happened. Like I don't see an alert popping up. So we can assume, as an outsider to this system, that maybe something like there's some sanitization or encoding going on, but potentially there's a bug. Maybe the bug is that it's only doing this on first-level keys of the JSON object, but not on nested ones. So we can go ahead and take it a bit deeper. And I'll put it in this bin field, OK? Instead of Gibson.js, we'll go with XSS there. It's also updated, but no XSS yet. What's the issue? Or what's not the issue? This looks OK. Commit, push to production, right? What can go wrong? Well, in fact, since we are in control of the data, the package manifest is a JSON of what this object does. But what if this wasn't a JSON? What if it was just a string? Try to refresh this. And yeah, I might have forgot a colon there. Thank you. Wait till it rebuilds. There we go. So now we have an XSS. But now this is XSS that has been added not due to our bad coding as developers building this application, but rather due to the fact that we're using a third-party component, which seemed to be OK if we had even some kind of security test that fitted with data, just not the right data. But it's interesting to see why this actually happened. So I'll go and venture into this app. And even more so, I'll go and get us a functional app. So I'll go ahead and remove this back. But more so, I'll open up my CLI here. And I'll run an npm audit, which is usually what you run if you no log file because not in the correct place. Which is essentially what you might run as a developer or have in your CI, and it might find some vulnerabilities. Let's see, has glob parent, which is a module that does something, moment, another module, and check. Some of these are dev dependencies. They're used just for building this, not for really deploying it to production, post CSS. But essentially, React.json pretty does not seem vulnerable here. So I want to take this back and relate this to this whole prior talk that Win has been talking about in terms of false positive, true positive, understanding this. If I had scanned this with a different tool, and you could use whatever works for you and whatever is essential for you to work with. I'm obviously gonna use Snyk here, but we do find React JSON pretty as vulnerable. So while before, if we hadn't found it, we might have thought as a developer, as a security person who's like auditing this, that there aren't any issues. But in fact, this is a known issue, just doesn't have a CVE. It did not go an actual responsible disclosure process with a researcher disclosing this, sending a MITRE report, all of these things. That's why some tools may be missing this. And it's super critical to use good tools that help you find those. Whatever you want to use, whatever works for you, that's great. Just make sure you actually check those kind of things. Now, I'm actually interested in why is this happening with this third-party dependency, which is what we can learn from this and what developers might learn. So first of all, we see that it has some issue with it. I'm going to go back here to my web app and show you a pretty cool tool that we've built that's called the Advisor. And what it gives you is you can search NPM, Python, Go, some other kind of ecosystems. But what it gives you is a sort of quantified metrics into what's the status of this package as an overall health, right? So React JSON Pretty is quite popular. It has 50K weekly downloads, which is a pretty high number. You can see that it's actually trending up, but it's not really maintained. It actually had no commit in the prior 3 years, no release either. So also, if now there's a new vulnerability getting disclosed, what happens? I don't know. Maybe the development team needs to find out a new tool. Hopefully, they do find out when the new vulnerability happened, if they use the right tool, and so on. There's a bunch of stuff that you can find here. But I want to dive again into some of the vulnerable versions which we had found, again, this vulnerability in. One of which you can see here, this is actually cross-site scripting XSS, as we have seen. If we dive deeper into this vulnerability report, takes you to this page, a bunch of stuff you probably all can browse through it pretty quickly, as you know, XSS and all of those things. But what's interesting is Snyk actually curates a lot of metadata on specific findings that it has. Anything from GitHub commits and issues that actually relate to the finding or fixing of this vulnerability. So this is super useful. For me as a developer and for developers that I work with, it really helps them understand context of also what's going on, why was it fixed, how was it fixed, maybe the fix breaks the application tomorrow morning, so they want to understand those kind of things. And this is where this is really interesting. So let's take a look at what's going on here specifically. Let's say that we have this XSS diff here with the vulnerability. We can see this is the example JS6, so that's not really interesting. This actually is this. I'll make this a bit bigger so you can all see it. This is essentially the source of this component library, and you can see that it has this get style. So there's a whole function of getting the style. There's a whole function of apparently a new way to encode for XSS, which maybe did not exist before, but it actually did clear some of it. So what was going on there? Let's see. Let's drop a bit more. OK, so this part of the code of this component was the one that actually was calling dangerously set inner HTML, which is the escape hatch to basically push everything you want to the DOM, regardless of taking care of vulnerabilities and XSS. And so it did this, but it did it in a somewhat responsible manner, right? It went on and called this internal function, which gave it the object and everything else, and it looks like pretty underscore pretty as a function. If I scroll down over here, it had this case of replacing this and with ampersand and greater than and less than with those kind of HTML encodings. So it basically did what React does to escape it. But the vulnerability maintained because it had a case where over here, if the JSON data that it was trying to get and parse had an actual issue with it, right, this try catch was not really being responsible encoded. And so if we go down here, you can see the actual diff is where dangerously set inner HTML is now getting returned back. And now, well, before did not have any XSS or anything relating to cleaning it. Now it does. Now it actually, they essentially wrote some extra code, which is pretty similar to what was working anyway on the prior commit. But they added this XSS clean function with this map. And now even those error cases and edge cases are getting clean. So this is how they fix the vulnerability. So it's interesting to know about it because it takes us into, it's a segue into like the last vulnerability here. But before that, kind of like this meme where hey, I'm using a React library, and I know not to use dangerously set inner HTML in my code because it could be dangerous, and I need to use things like DOM purify or other dependencies to help me clean this up. But it doesn't mean, even though your developers are very proficient in the framework maybe, that the components that they use are also following the same guidelines, because essentially this is open source. These are all maintainers out there, and they're all trying to do, build something, but they may lack the skills and the understanding of what may happen, just like we've seen here for a dependency that has 50,000 downloads in a week. So this might happen, and that takeaway is, kind of like avoid dangerously set inner HTML, know what dependencies you're using, also scan for those third-party dependencies. We've seen that's not working with some tools, so try to find out tools that actually work for you. But I actually want to take that again as a segue and say, well, we've scanned for dependencies, and let's say that we found a business case in which we actually need to use dangerously set inner HTML. There's a business case for it. We said if you escape it, that's fine, right? Like I just show developers yourselves how I actually pass XSS into a value of a dangerously set inner HTML, which is a dangerous API. And there wasn't any XSS there. So not great, not terrible. I don't know. Let's see. Let's see in a sec. Think about this custom logic. I have a picture I want to display on the page. Like you go on Twitter and you see images. And then you might want to specifically style that in a specific way. So you enter this sort of HTML tags into it, the image source, and then an alt tag like you see, again, on Twitter or other platforms, where you can customize and set an alternative text in case the image is not shown or if someone needs to use it for accessibility. So all of that is pretty straightforward, and this is how people will use it. And the only thing that we need to do to use it is just copy-paste that HTML, right? So the XSS to clean it. So let's go back into the app. I'll clear up some things here. So there we go. We have this dangerously set inner HTML. I have alt as outer screenshot description. If I go to my database, outer screenshot description, now it's lorem ipsum. So I want to make sure that if I add something bad here, nothing bad actually happens. Let's say. If I go down a little bit more, look at what's going on here, this picture. OK, need to zoom in a bit less, maybe. So lorem ipsum is the value for that. Let me take that maybe a bit bigger so you can see it. There we go. So we know this works currently as intended. And I'll go ahead and change this to image src x on error. Alert, maybe try this to inject it. If I do, refresh, nothing happens. You can see it kind of like broke here really bad. And even at this point, potentially, like put yourselves in the shoes of developers. They might think they're getting protected because of something, but they're not. Nothing new happens here because simply I did not really inject it in the correct attack vector to cause and trigger the XSS. So all I really had to do was to say, hey, I'm actually within a tag. All I need to do is close it, start a new one, and let the code of the app close it for me. So if I do that and go back here, I get the XSS pop-up. OK, so also be mindful to this kind of things where developers may have assumptions, but are sometimes flawed. So I want to fix this. And I, as a developer, saw how one developer fixed their issues, which is this. So what do developers do? Also we do, right? As security people here. Let's copy-paste that and make use of this. So I'll go ahead and add it here. This is in a format of TypeScript, which I'm not using, so we're going to go and clean this up a bit. Did not need to declare any types. Cleaned. I think no code issues at this point. And I basically have my XSS. It's pretty simple of what's going on here. It's just replacing and doing the encoding properly. So let's go back into the app and see that we've mitigated it. I remind you, I haven't done anything else here, so I probably need to run this here to make sure I encode it correctly. The moment that I do, looks like it's done. So this is how you encode XSS and mitigate this vulnerability. Or is it? We've seen it working for a different library, so why wouldn't it work here? It's the exact same context. Or is it? So it's not really the exact same thing, right? Because we're now encoding for before we were encoding for an HTML element, but now we're encoding for the value of an HTML element, which is different and requires different context for encoding it. So while this vector that we saw before doesn't work because some of this XSS have actually been able to mitigate it, if I had done something like this payload, we now get the XSS again. So again, another XSS, just a different payload. So what are we actually learning here? We're learning here that the fact that I'm actually giving it an XSS and copying it from one to another, we need to apply some judgment and understanding of how these things work. Need to apply some judgment into what XSS escaping or encoding actually does. Where does it apply? Why do I need to clean it differently between inputting it into things like URLs, like values of attributes, like CSS values, all of those things. And those are very deep expertise that you as security people have, but developers often miss. And that is where you kind of need to work with them to understand and to let them understand how to mitigate this and why this is an actual issue. So with that said, I'll go ahead and give you the last takeaway here, which is please don't use dangerously set inner HTML anywhere at all. That's an escape hatch. If you do use it, please use it responsibly, use it with context-aware encoding and all of those things, and code review it properly. And that's it for me. Thank you for coming in and enjoying the live demo.
Go.
Any questions?
We don't have
There we go. There's one there.
But you can start. I know, you should be able to start doing that.
Hi, thank you for the talk. It was very interesting. I was wondering if you tried to fill a CVE for the first vulnerability you showed us.
If I try to do what?
Build a CVE.
Yes.
And they didn't accept it?
Oh, so you could file a CVE for that afterwards. Maybe this one already has it. We could check pretty easily, I guess, because it was right here. But let's see. So this one doesn't have a CVE. If you ping the Snyk security team, just email them and tell them to assign this a CVE. They might do it, so you can go ahead and do that. The reason for this not having a CVE is, like we said, the problem of security in open source, right? Like researchers, someone finds this vulnerability, they open an issue on the GitHub repository, maintainer hopefully goes there and fixes the issue, and that's it. Like it gets stayed there. The whole point of Snyk being here, kind of like monitoring that kind of chatter, having that intelligence behind the scene to go ahead, find them, and add them to the database, which a lot of other tools don't actually do.
Yeah, just finding a bit kind of sad that there's a NPM audit that I think is based on the CV database, and you don't do the extra step to also make it available to everyone.
Correct. There's an ongoing an OpenSSF discussion. If you want to join that one, I'm happy to get more people involved in terms of uniting the databases and making more cases for cooperation between the tools. So thank you.